In this video, I am going to be talking about the circle theorem that concerns chord bisection. Specifically, I'm looking at the theorem that says the perpendicular line from the center of a circle to the chord bisects the chord. Now, a couple of words there to pick up on. Perpendicular means that it crosses at a right angle. So here what we're saying is we've got the radius and we've got this line and we're making a right angle. That's what the perpendicular bit means. The chord is a line that goes from the circumference to the circumference, not necessarily through the center. So if it went through the center as well, it went from the circumference to the circumference, passing through the center, that would be our diameter. But this one doesn't cross through the center, it just goes from the edge to the edge. So we call this one a chord. And what the theorem is saying is that both sides of this chord have to be the same, that we've got a bisection, that it cuts it exactly in half. Because this is a theorem, we can prove that. So I've got an image here, which is just showing what's going on. I've got a chord, and I've got my radius, and I've got an angle between them, which has to be a right angle because we know that it's a perpendicular crossing here. I just need to prove that it's a bisection. I need to prove that these two lines here are equal. To do that, I'm going to form two triangles, using again this technique of adding in extra lines, and in fact adding in extra radii. So both of these lines are radii. This black one isn't necessarily, well, it is if I go all the way to the edge, but not if I only go to the chord. This is not the same length. But I can see that these two red lines are the same length as each other. Now, what I've got so far is I've got two triangles where the hypotenuse is the same. This red line here has to be the hypotenuse. These two hypotenuses are the same. Obviously, they also both share this line here. And we have a right angle in both of them. This would be a right angle as well. So what I actually have here are two triangles with the same hypotenuse, the same side length, and a right angle. Now we know from our work with congruent triangles a while back that this is an example of RHS, right angle, hypotenuse, side. That tells me that these two triangles here are congruent to each other. These two triangles are the same triangle. Well, if these two triangles are the same triangle, then it must be true that this length and this length are the same. Therefore, we have a bisection when the radius crosses the chord.